Hello students, this is the video for our most missed skills on your 4.5-week assessment. Now that's the test that you took with a substitute. Coach Pitt Mason, I believe was her name. So we're going to be going through about, I think, 7 questions, that were missed by more than 25% of the students. So I want you to go through, I want you to take notes from the word problems, I want you to copy the simpler expressions. That's the cat that you hear in the background there. Little excited with a toy. So let's get started.
Okay, so let's jump in with this first one that was missed by more than 25% of the class, 25% I should say of all of my algebra students. I think the reason that we're missing these problems with absolute value and square roots, etc., is that we just didn't do a lot of practice in class with this stuff. So we'll make sure we get a whole bunch of it in the next week before our benchmark. So what is the value of the expression? The absolute value of the square root of 36 minus 28 divided by 4. Now, you guys know that I kind of have an issue with this obnoxious little symbol right here. I think that it's outdated, and I think we need to stop using it. And I want you guys to think about the difference it makes in your mind if I write it like so. This means exactly the same thing, but it doesn't cause the order of operations problem that we seem to be having with the problems that we're learning how to solve. So instead of seeing that as a situation where you're not sure whether you should subtract or divide first, I want you to see it like this one, in which case, oh, that's easy. Well, that's 6 minus 28 divided by 4 is 7. And now I have to remember that when I subtract and get negative 1, the absolute value of negative 1 is indeed positive 1. And that was the only correct answer to that problem. So recall, again, that you need to think of those absolute value bars as a grouping symbol where you are doing all of the math inside till you get a single value, in this case negative 1, and then finding the absolute value of that. Excellent. Let's move on. Okay, which represents the addition property of equality. Your properties of equality, those are the properties, that we use to solve equations. Those are your equation solvers. It's the doing the same thing to both sides properties. So what you're looking for here is where you've done the same thing to both sides and it's addition on both sides. So look carefully through these. You have an addition equation in A, x plus 3 equals negative 8. I don't see the same number added on both sides. You have another one here, variables on both sides equation for B, x plus 4 equals 2x plus 8. Again, I don't see the same thing added on both sides. X minus 3 plus 3 is equal to negative 8 plus 3. Ding, 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 ding. That's it. Right there. Same thing done to both sides. We have the same thing here, but that's subtraction. We're looking for addition. So the correct answer on that one was C, and we'll see some practice with that in class as well. Next one. This is an order of operations question, order of operations problem. Okay, so order of operations. So we are making sure here that we recognize the correct order of operations, and we want to be looking at what operation we're supposed to be performing first, second, third, and so on. But we might have some confusion here. So let's remind ourselves real quick exactly what that order of operations is. All right, so parentheses. That's operations inside parentheses. Do we have any of those? No, we do not. Exponents is next. We kind of do have exponents here, one exponent here. And this is kind of a cool thing just to do as like an aside. The cube root of 27. That is what cubed, what to the third power is equal to 27. Now, I had several of you tell me on this 4.5 weeks test that you did not recognize that cube root, that I've never seen that before. Go back in your notes, look back in your notes, simplifying and evaluating expressions, it's there. All right, so the cube root of 27 is what to the third power is equal to 27. But the reason I say it's like an exponent is that the cube root of 27 is the same thing as saying 27 to the 1/3 power. Now, you don't need to stress about that because we'll learn that in Algebra 2. You can pretend I didn't tell you that. But that does tell you what order that we need to do things in. Okay, so we need to go ahead and simplify that first. The cube root of 27. What to the third power is 27? Well, that's 3. 3 times 3 is 9 times 3 is 27. So I have 3 times 32 plus 12 divided by 4. I need to do the multiplication and the division before I can do anything with that addition. Okay, remember that in your order of operations. Multiply and divide from left to right as they come. Add and subtract from left to right as they come. So 3 times 32. 3 times 30 is 90, excuse me. 3 times 2 is 6, so 96, I believe. Plus 12 divided by 4 is 3. So we should have ended up with 99 is the only correct answer for that one. Okay, do remember your order of operations. Which brings me to the next one, which was basically the same idea. We had another cube root of 27 plus the square root of 25 minus 8 plus 4. So again, order of operations, cube root of 27, what to the third power is 27? 3. What squared is 25? 5 minus 8 plus 4. So 3 plus 5 is 8, minus 8 plus 4. 8 minus 8 is 0. 0 plus 4 is 4, and 4 was the correct answer for that one. All right, only 3 more. Okay, this problem, our issue with this problem is wording. So again, let's read it together, and you'll probably remember this from when you did this test yourself. The closing price of a share of stock in company XYZ is $25.69 on Thursday. Thursday. If the change from the closing price on Wednesday, is down 75 cents, then what was the closing price on Wednesday? So the price P on Wednesday went down 75 cents to result in the price from Thursday. And the reason this was such a difficult question for us was that you had to, you're either adding or subtracting. And both answers are there. And that's why it makes it more difficult. If you mapped it out like I did, you should recognize that we are saying the stock price, that's a P, it just ended up kind of funky looking. There we go. The stock price went down 75 cents, giving us a price of $25.69. Meaning that in order to solve this, I am adding the 75 cents to find out the stock price on Wednesday. If you just punched the buttons on the calculator and you didn't think, then yes, you ran the risk of making a mistake there, which Ms. LeCompte is also doing by trying to do the math out on the iPad while she talks. Multitasking, as you know, is not always my best skill. Let's go with skill. Okay, $26.44. We had to add that 75 cents because we're going back in time. We're going from Wednesday to Thursday. So we had to think about the way that would be set up. All right, 2 left. This one, what's going to bother you with this one is when we talk about it a little bit with the calculator in class. I want you to recognize that, yes, we do have fractions here. No, I know most of you don't like fractions. I think most of you recognize that you're adding 4/5 to each side here. But what you may not recognize is that if you were to type that straight across your calculator, this right here, 3/8 plus 4/5, and then use your math double enter, math, enter, enter, it's going to give you the correct improper fraction answer. The only problem here is that these weren't improper fractions, so you actually probably don't even need the math enter, enter. You can probably just find it as a decimal. I'm going to go ahead and do the math with the common denominator of 40. So I have 3/8 plus 4/5, and we're going to make them into 40ths. 3/8, we're going to multiply by 5 to get the new numerator there. 4/5, we're going to multiply by 8 to get the new numerator there, giving me 47 40ths, which is the first one, which is F. Okay, and also, if you're trying to put a mixed number into your calculator, remember that you may have to put it in decimal format. Okay, last one. Okay, this one's kind of a book, so let's get started. Stephen wants to buy a $565 bicycle, so he needs $565. He has no money saved, but can deposit $30 each week into a savings account. Each Friday, it says, so that's each week. However, before Stephen can buy the bike, he owes his sister $65. So he needs to give his sister $65. For how many weeks will Stephen need to deposit the money into his savings account before he can pay back his sister and buy the bike? Well, first of all, identify your unknown value. This was easiest for me to do with an equation. If you figured it out correctly without an equation, well, of course that's good. But you don't have to assume that you are going to be able to find the answer without having a nice, happy equation to look at. So let's define a variable and write an equation. All right, so we're going to call W number of weeks. He's saving $30 per week. So $30 per week for W weeks, remember, would be 30 times W. We have to take out the money he owes his sister and set this equal to $565. And that's the equation we end up needing to solve. So I'll jump right in and go ahead and start solving it. Okay, the reason we end up adding the $65 to both sides is that he needs more than $565. He needs, in fact, 0, carry a 1, 12, 13, carry a 1. He needs $630 to make sure. Oh, I caught my mistake. Did you catch it? No editing for me today. Caught my mistake, which, of course, famous last words. I'm sure I'll have to edit something else. All right, so anyway, I was trying to explain that we're adding that because he really needs to save $630 because his sister wants her money. Okay, finally, 30 into 630 is going to go 21 times. So it's going to take him 21 weeks. If you worked backwards and you multiplied, you might have taken $30 and multiplied by 10 weeks. Okay, that's 300, so that's not enough, and so on. But look, wasn't this faster? Wasn't this faster? I think it was. All right, guys, I will see you in class.